Alright, let's see if we can get this going. Just making sure everything's running correctly. Don't want to be talking to myself this whole time. Alright, the internet can totally see me now. Oh, this is cool. Okay, so this is going to be the first of hopefully many of the IRIS live streams. Let me close all my stuff out of the way. I'm going to be doing some question and answers about what IRIS is doing. I'm going to be demonstrating it. Should be really cool. For those of you who don't know, IRIS is a attempt at an artificial general intelligence. It's not there yet. it's not even close. But it's an interesting approach that I'm taking based on causality and learning causal relationships rather than going with the, I guess you could say, more traditional correlation approach. And I've got some really cool results from this. If you're not already familiar with IRIS, I've got, I'll pop that open real quick. Since we're streaming, let's do it. IRIS. There we go. This is the IRIS project website, iris-ai.com. I've got a whole bunch of info. Oh, looks like I got my. I'm not going to start that up. It's got more info about how it works and stuff, but we're going to go into that here in a minute. First, I want to give a huge shout out to my partner in crime, Luke Dickerson. Early last year, not too long after I did my 2017 year in review, Luke reached out to me and told me about how cool he thought the project was. I was already planning on a whole bunch of stuff, as you can see at the end of the 2017 review video, and he said that he wanted to be involved. And I thought that was cool, because he knew Python. I didn't. And I had the whole project was written in a thing called Game Maker Studio, which didn't run it really well. To give you an idea, well, you know what? Let's just fire it up, and I'm going to talk to you a little bit as we, give you something to look at instead of just this empty screen. Let's do that. All right. The puzzle game driver. Now, the puzzle game is Luke's. Luke wrote the game. He converted the game from Game Maker Studio into what IRIS is doing. Let me pause IRIS for a second. Okay, so we'll talk a little bit about this. But this game environment that you see here was originally created in Game Maker Studio. The whole AI was running in Game Maker Studio, and it ran very, very slowly. Each frame of doing something took minutes to perform, especially during the planning process and learning process. So I wanted to convert everything over to a different language, something more useful, but I didn't know Python. I knew that OpenAI has the awesome gym environment. I wanted to throw IRIS against the gym environment. I still plan on doing that. And so I was like, Python is awesome. And when Luke said, hey, I know Python, maybe we can do something with this, I said, yes, let's get together. He and I worked on converting and porting the code over from Game Maker Studio into Python. I got a much beefier computer than what I've had in all the other previous videos. So now IRIS is running just super smooth, just gorgeously. And a lot of improvements happened along the way in the last year, because I was teaching myself Python, and Luke was kind of following along and helping me clean up and fix my newbie programmer mistakes. It's worked really well. We are finally at the point now where IRIS, I'm happy with where IRIS is at. It is at an equal point. It's a little slightly bit better than what it was in the Game Maker version. Hello, Jeremy B. How did I get the idea for IRIS? That's a very good question. IRIS was kind of based on my own desire to have a video game playing AI, one that learned how to play games and could just play them, because I'm a hobbyist video game developer. That's kind of my thing. So early on in my video game development hobbyness, I wanted to create AI in my games, but I didn't know how. This was 10, 12 years ago. And so I didn't know about, pathfinding and decision trees and all that kind of stuff. And so I wanted something that I could just drop into my game and have it figure out my game. So that was the kind of the inspiration. I knew nothing like that existed. And so it kind of set me on this adventure of trying to figure out, one, why that didn't exist, and two, maybe this is something that I could make and have it exist. So it's kind of inspired by when I'm playing. It was a lot of introspection, a lot of trying to analyze my own thoughts and processes of when I'm looking at new environments, like a new game or something that I'm playing. How am I learning in this new environment? How am I learning how these different things work, how the different parts work, how I can influence the game world, and to achieve whatever objective the game happens to have. So that was kind of my inspiration behind this. Now, this game environment in particular is a simple grid world game environment where the player is the AI. The AI is the blue square, and on the left is what the game actually is, but on the right is a simplified version of the pixels. So, Happy New Year to you too! Each one of these grid locations that you see here is represented by just an integer. Okay, 0 for empty spaces, 1 is the character, 2 is walls. So the idea is that instead of passing every single one of these pixels, because that's a lot of data crunching, I am just passing, simplifying down these pixels into these values. So what you see on the right over here is what AIRIS sees, how AIRIS sees this game environment. And the goal of the game is a little blue square, walks around, picks up batteries. So I'm just gonna kick this off and let it do its thing. There we go. And you're gonna see very quickly that AIRIS figures out how to navigate and operate in this environment. It learns that it can move. It learns that walls prevent it from moving. It learns that it can collect batteries. It learns about each one of these different elements, and it quickly can just go right through levels like nothing. Oh, hey. Yeah, I know. It was kind of like I'll give everybody a warning next time for the stream and when I'm starting. So you're kind of seeing an output here on the left side of basically what the AI is doing. So this is a little more complex level because there's a whole bunch of arrows in different directions. These arrows prevent it from going left, but it can move through them in any other direction. This arrow, so basically it could only go up through here, and then it can't go here, so it has to learn that it can go down here, and it just kind of works its way through experimenting with the different combinations of objects. And again, this is what it's seeing over here in its mind. Yes, these maps are not procedurally generated, but what you're seeing right now is a clean slate version of AIRIS learning these levels for the first time. So it has not been trained on these previously. Since I started the stream, I cleared out its mind, and it is a blank slate. So I've created like 10 levels, and well, is it 10? I think it's 10. 10 or 15, and they kind of grow in complexity. I want to create a lot more, I'm going to talk a little bit later about some of the limitations that IRIS currently has as far as these go too. But so you can see it kind of working its way through and playing these levels. It's what am I saying here? I'm getting ahead of myself. So yes, when the agent is standing still, it is thinking, and it is modeling out an action space of possible paths that it is generating based on the observations of its interactions in the game world so far. So the AI agent only has 4 actions it can do: up, down, left, right. And so it is modeling out if the spaces next to it is empty, it will model itself moving into that space. And actually, let's see. I'm going to pause it when it on its next step. Here we go. Come on, come on. Okay. So once it figures out, here we go. All right. So awaiting plan approval. This is a cool thing. It is a general learning algorithm. You could not put it into Far Cry right now, and I will explain why that's the case. Right now, for planning purposes and all of that, it's really only good at it kind of lumps all of the actions or all of the things that happen on screen under one causal action. So like if it moves left and 4 different things happen on the screen, like an enemy moves and a wall moves or something like that, it's going to associate moving left with all of those other actions. And that's how the knowledge is stored right now. I have it set up that way because originally, with this whole thing being made in GameMaker, I couldn't realistically process more than one causal interaction at a time. It would take 20 minutes or so. Yeah, that would complete and explore narrative-based game. That would be amazing. Like right now, I can't even throw this at an Atari game and have it really understand what's going on. It might be able to figure things out after a long while and a lot of data, but until I separate out and start processing causal relationships on an individual basis, like an enemy moving has its own causes, you moving has your own causes, some other object moving has its own cause, instead of lumping all the causes together like it currently is, it will really only work well in like turn-based type environment, kind of like this, like a roguelike environment where it moves and everything else, and then something else moves, and it would probably be able to handle an environment like that okay. But going back a little bit to the modeling, when I pause it, I don't think Atari games measure general intelligence. Well, yeah, and that's true. A singular Atari game. Oh, hello, Shori. A singular Atari game is not a good judge of the intelligence of a system, of general intelligence of a system. DeepMind creams individual games, right? It rocks, and it does, and it can even do some. I think, don't quote me on this, but I think I've seen some research done where it was even able to do a couple of games all with the same model, without having to retrain an entirely new, fresh from the start thing to be able to play those other games. The point of IRIS is that IRIS should be able to play all the Atari games and learn all of the Atari games without forgetting previous knowledge about other Atari games. So it will learn all of these different things and be able to learn all these different game environments and then retain that information between the game environments. And one of the ways that I tested that out is with character recognition. So there's the MNIST handwritten data set, right? And the MNIST handwritten data set is a completely different problem, right? Recognizing numbers is a completely different problem than doing this game environment stuff. And So what I needed to make sure that the system could do was that it could do both. Can it learn numbers with no other coding than what is currently in it, and also be able to do the puzzle game? And it can, which told me, okay, I'm onto something cool here. Yes, it is turning a game into a problem and modeling accordingly. As to whether or not that is thinking, that is definitely falls into the philosophical realm, and is, I think we've been debating that for centuries. So I'm going to steer away from that one. So just jumping back a little bit about modeling, I paused Iris right now, and when I pause Iris and it says, you know, it's awaiting my plan approval, I can look and see each step that the AI is thinking in its head. Okay, so if you see over here on the right, this is the start. Its first plan is to move right, and this is what it thinks the world will look like when it moves right. And then step 2 is it's going to move up, so it thinks that when it moves up, it's going to generate a wall there. Now see, this is cool because it's showing an incomplete understanding. It doesn't quite grasp what happens or how this works when it's on an up arrow. Now I think, I'm just tossing this out there, but I think it learned that from the previous level when there was all those arrows and some walls at the top. It learned that when it tried to move up, when it was on this arrow, there was a wall in the way. So that's kind of what it's thinking is going to happen. There's going to be a wall in the way. So it doesn't quite have 100% grasp of how the world works yet. So if I give it the plan approval and let it do its thing, okay, now it just learned something new. As you can see down here, plan approval, something unexpected happened. There wasn't a wall. I learned something new. It learned that it could move up from these locations, and there wouldn't be a wall generated there. It will actually move there. So now it doesn't know what's going to happen. So this is cool. So we have a predicted result of start. So in start, you're here, which is step 0, is where it starts. It is predicting what happens when it moves right. It hasn't yet moved right on one of these right arrows, so it doesn't know what's going to happen. So it can't model what's going to happen yet. So it's going to try it, and it's going to see, hey, this is what happened. It was unexpected. I learned something new. Great. From here, it's got 6 more steps. Let's see what it's going to do. It thinks, look over here. So it thinks that it can move down from here through the wall and then move over and collect the battery. So that is what it is currently modeling in its head. Imagining is what's going to happen. That's obviously not right. So it's going to do that, and it's going to learn, oh, okay, I learned something new because I tried moving down and the wall didn't get out of my way, or I didn't move through the wall. So that's something new, and it learned another interaction in this game world. Now it's got 6 more plans. Let's see what it's going to do. There we go. Now it's learning, it's beginning to understand how the world works, and so now it's being able to do its particular task of collecting batteries. Let's see. So we'll just kind of let it. I will disable the pauses, and we'll just let it run for a little while. Okay. So Jeremy asks, what are my plans to improve Iris? That is a very good question. Right now, the plan to improve Iris is to get it separating out causal relationships into the individual cause and effects instead of lumping them all together. Once I do that, I can put it against OpenAI's various gym environments. There are a lot of them, and the goal is to get Iris to be able to learn all of these environments and be able to switch between them seamlessly without forgetting the previous game environments. So here you can see it's kind of wandering through and collecting batteries and all that kind of stuff. Now there's an interesting moment coming up here as soon as it figures out how to go collect that other battery. In the next level is a new obstacle, which is keys and doors. So you have to collect doors are locked. You can't move through a door. It acts like a wall. So you have to collect the key to unlock the door, which opens the door and then lets you pass through it. So that is something that IRIS has not yet experienced in this particular playthrough, and so eventually it'll figure out how to get to that battery, and it'll get to the next room, which has the doors and keys. And interestingly, it takes it no time to figure this out. It tries moving against the door, it can't. So it says, okay, here's something new. Let's go try that. Oh, a key. All right, a key works. Oh, hey, look, the key did something different with the door. The door now opens. I can get through, and now I can collect the battery like I want to. Which is really cool, because it happens, it's very quickly that it's able to adapt to brand new problems. And a lot of that has to do with its previous experiences with other objects. So it knows that when it moves against walls, it doesn't move. When it moves against arrows, sometimes, depending on the arrow, it may move into it, it may stop it. And so it kind of uses that as a guide for when it's not sure what to do. It will think of something new to do based on some of its previous knowledge and try that new thing, and if it learns something new, then it replots out its original plan to collect the battery. But does it ever develop common sense? That's a good question. I can't say that it does, just because it's something that I'm not far enough along to be able to verify. It kind of seems like it does in just that door key interaction, but at the same time, that's really not enough information to say that it actually is. You know, it's easy to put a human-centric bias on what you're seeing, and like, oh well, it's doing this because, you know, that's the way I'm thinking about it, but that may not be what the AI is thinking about it. So Jeremy says, can it create a model of the universe and see how red things tend to be hot? In theory, that should be the case. It should be looking for correlations between previous interactions and new things to kind of try and make how similar is this new thing to something else I've experienced. So in theory, that's kind of what's going on. On the back end right now, that's very, very limited. Primarily because, I mean, it's working with you know, a very simple pixel environment. There's not much you can really correlate between individual integers, except for, like, if it's a 1, is the 3 closer to the 1 or is the 2 closer to the 1? And, you know, there's that kind of thing. And that's what it's doing right now. But that's not really as viable, I think, in like a real world or more complex environment. I'm probably going to have to add additional correlation knowledge there. So, or addition, not knowledge, capability. So this level sometimes presents an interesting trap for the AI, and this depends on how it learns and what it oh, thank you. Appreciate that. So it depends on how, and this is kind of interesting because it depends on how it learns, and what it learns in the very beginning will affect how it plans and processes things later on. So sometimes it'll get stuck in this level, sometimes it won't. But a lot of this, the reason why it would get stuck is that early on in the level, there is a battery right here for it to collect. And with the fire being right here, it is easier for it to collect the battery and then go over and reset the level and then collect another battery than it is for it to collect a battery and then collect a key and then go unlock a door and get to the next battery. So it causes kind of like a loop already. In this case, it didn't get stuck, which is pretty cool. Good job, Iris. Thanks for looking good for the first live stream. Right now, this is a new interaction. It's learning about fire extinguishers and fires. One fire extinguisher puts out one fire, so it has to do kind of a careful planning here to be able to grab both of these batteries. It has to use the first fire extinguisher on the bottom so that it can get to the other fire extinguishers, so that it can get through and these two fires to get to the battery. So it's a somewhat more complex challenge than the other levels, and they're kind of going up more and more in complexity. And the next level after this is a great example of one of the limitations that IRIS currently has, that I'm planning on, that I have an idea of how to expand on, but it's not there yet. And that is, excuse me, that is hierarchical goal setting. So because its goal is just to find a battery and move on that battery, what it's doing is it's modeling out ways of getting to that battery. I don't really have a great way to display that, but essentially what it's doing is it is modeling out, okay, if I go out here and try and push against these fires, I'm going to reset the level. So from here, let's see, what else can I do? I can go up here and I can grab this, and I can go back down and I can push through one of the fires. And so it'll push through one of these fires and then it'll get stuck. And it's like, okay, and then I reset the level. And so it's basically, it's kind of like almost a brute force method of searching the state space. It's going here, and then it's going here, and then it's going here and here, and this is letting it get past, so it's going to go through here and bounce back and forth, and it uses up a lot more thought process than needed, right? Because if it was a human playing this, we'd look and we'd say, okay, there's two fires in the way. There's one fire in the way. I've got one fire extinguisher, so I need to get rid of this fire so that I can grab these two so that I can get through here and get to this, right? Whereas the AI is just kind of generating more and more state spaces, and it's a directed state generation, but it's just generating out and generating out and generating out and generating out, and eventually after enough, and you can see over here where it says the plan depth, so there's 320, it's up to 325 actions. Now, it shouldn't take 325 actions to complete this level, but it needs that much planning in order to model out each of these different things until it finally reaches a combination of states that allow it to pass through and collect one of the batteries. And in the later levels, that really amplifies. If it can't directly get to a battery, it takes a lot of steps because it'll go over and it'll try to get the battery, something will block it, and so it'll just keep modeling out, and something will change, like it'll collect something and then it'll model its way all the way back and try it again. Nope, that's not enough, I got to go back. Oh, something else changed. Okay, here we go, got to go back, try it again. And so it's bouncing back and forth, and it's really, really inefficient. So what needs to happen is it needs to be able to recognize obstacles as like sub goals, and so what it needs to do is it needs to look and say, can I get to the battery? No, I can't. Why not? There's fire in the way. Okay, so now instead of its end goal being get battery, its new goal is to put out the fire, or interact with the fire in a way, or interact with something in the level in a way that allows it to achieve its goals. And so it would look at all the things, all the different ways that it has interacted with a particular object. If it's a wall, it'll look at all the ways it's interacted with the wall. Has the wall ever disappeared? No. Has the fire ever disappeared? Yes. Well, why not? How has the fire disappeared? Well, it's disappeared when I've collected a fire extinguisher. And so it would, okay, recognize that there's fire here, that's in the way. Goal, put out the fire. Great. How do I do that? Collect a fire extinguisher. New goal, collect fire extinguisher. So then it would go collect the fire extinguisher, then go put out the fire, then collect the battery. And have a sequence of goals so that it would have a much more directed planning process. Because if you were to tell it, okay, go collect a fire extinguisher, it would just go directly there and collect the fire extinguisher. And then you tell it, okay, now go put out a fire, it would directly go over and put out a fire. And you say, okay, now go grab the battery, it'd be able to go grab the battery. And we want it to be able to do that all on its own, right? We don't want to have to tell it all of these individual steps to be able to do its goal. We want it to be able to figure these steps out on its own. And so while it can model out a series of kind of brute force action space to get there eventually, and it does get there, it will solve it. It just takes a long time, and a lot longer than it should. So that's one of my future steps. Hase, sorry if I butchered the name there, says, does for each choice the player onto enter different game path? I think what you're saying is, does it result in a different game path? Like if you choose this battery over this battery, does it result in going to a different level? No, but that is something I do want to test out. And one of the reasons I want to test that is I want to see how well IRIS can process and think in advance. So if I was to restart this whole thing, which I can do, hang on, let's close it out. We'll close it. Close. There we go. Okay, now its memory is saved, its knowledge is currently saved, so if I was to fire it up again, it's gonna fly through these levels because it knows it retained the same knowledge, so it knows exactly what it needs to do now. What am I thinking? What was I thinking? Oh, I want to be able to start it off on the first level. And it looks like it's getting confused, but if you look on the right here, you see it's trying to move left to collect the battery, and move down to collect the battery, and there were walls in the way. So that's part of the goal system that was causing it some confusion there. So what I want to be able to do is start off in the first level and say, okay, go collect a key, and give it the objective of collecting a key. And this is after resetting it, having this prior trained knowledge, and have it say, okay, to get a key, I have to beat through 4 other levels before I can get to the key. And then I want to be able to watch and see it actually modeling its way, completing all of these levels to acquire the key. And I think it will be able to do that. But again, that's something I haven't yet tested. So this is pretty raw, as in this is this is not much further along or much more developed than it was early last year. The big difference being that it's ported to Python. It runs so much faster. The code is so much cleaner. Everything runs better. And so I'm able to do a lot more. I'm able to test a lot more. I'm able to and do something like this, where I'm doing a live stream showing the AI, learning these environments, and learning the game, and being able to play and complete the levels. So I'm really excited about that. I'm really excited about the fact that we have these new. Hang on a second. Let's see what it's trying to do here. I'm curious. What is it trying to do? Okay. All right. Now, see, in theory, it should be able to just zip around and collect these batteries, no problem. But it seems to be more interested in experimenting with these walls and trying to just push through the walls for some reason. That's interesting. Okay, well, that's fine. We will let it do its thing here. So one of the other cool things about this system that I want to develop further is the visibility of it, the transparency, being able to see what it's planning, how it's planning, and why it's planning it. And that's something that I'm going to be working to expand on, because I think transparency is going to be is a super critical thing for any artificial intelligence system that's going to be put towards like a real application. I mean, for toy things like this, nobody really cares why it's deciding to try pressing up against the wall instead of going through and collecting the batteries. But in a more real-world situation, we would want to know why it's doing what it's doing instead of just completing the level. And I'm actually really not sure why it's having so much trouble with this. That's the other thing I've noticed about about IRIS, and this must be a bug. I'm guessing it's a bug in my code somewhere, but sometimes I will start up a version of IRIS and it will act super smart and plow through levels and have no problems whatsoever and just be super smart. And other times I'll start it up from scratch and it'll have a really hard time with certain things. Like it'll start off good, and then it'll have some new interaction that just throws everything else off. And so it starts thinking things like, when I move in an open space, I'm going to turn into an arrow, and just it's almost like its knowledge gets corrupted or out of sync with the actual things that are going on in the game. So I think that's probably just a bug in my code somewhere. Like I said, I'm still learning Python, so this is all new stuff. But big shout out to Luke again, Luke Dickerson. He's awesome. Without him, I would still be trying to get IRIS to anywhere near this point. He's really helped me out. Doing the whole Python programming, learning Python, figuring out all that stuff. He wrote this conversion, this game environment. He also wrote, I'm going to stop this because it's stuck. She's stuck for some reason. So let me toss this out there real quick. We're going to, I actually haven't tested this part. Okay. Yeah, there we go. That seems to be working okay. So this is IRIS doing the MNIST training with the knowledge same knowledge. Like it's the same knowledge database. And you can kind of see that going on over here. If I pause, there, let's pause. You can see that there's still some knowledge. Like there's a new move action called reveal, which will reveal the answer of what a particular number is compared to what it's predicting it was. So like I think this is an 8. I was wrong. I learned something new. I think this is a 1. I was right. I think this is a 7. I was right. But it still has like the battery and all that stuff because it still is trying to do the same kind of thing where it's creating it's trying to create a like a plan, but there isn't really a plan. There's only one action it can do: reveal the answer. So it's just kind of predicting what these numbers are. Based on what it sees, and I'll let it keep going here for a bit. And this is just a small subset, a random sampling of MNIST. 600 images from the training data set, and then I think another 100 or something like that from the test data set. And so this knowledge is being stored and alongside all of the knowledge of the puzzle game. So it's going through and it's doing this and learning all these numbers. But if I close this out, fire up the puzzle game, it's still going to be able to play the puzzle game the same as it was before. It probably will still get stuck on that other level because I think something weird's going on there. But I mean, we'll see here in a second. I'll just let it finish the MNIST thing. It's almost done anyway. Its total accuracy. Across, to do the full data set of 60,000 tests and like 10,000 or 60,000 training, 10,000 tests or something like that, the end result, oh, there we go. So it just closed out 74% accuracy. Not super great, but pretty good considering it only trained on 600 characters and then tested on 100. But for the full data set, when I do the full run, which I won't do on stream because it takes a while, it's able to get 90, like right around 94% accuracy, which I mean compared to the specialized MNIST neural networks out there. That's horrible because those guys get like 99, 100% accuracy, but they also can't play a puzzle game. So that's my focus here, is that I want a system that can do both. So I just fired up this puzzle game. I haven't changed the knowledge. It's still same knowledge, and so it's operating using both knowledge sets, and really what it's the way that works is that it's looking at all of these pixels, right, all of these different pixel values, and seeing, does this environment look like the puzzle game, or does this environment look like a number? And if it looks like a number, it's gonna predict the number output. But if it looks like this, it's going to be able to predict what happens in the puzzle game. And so it's really input based. If I was to make a puzzle game level with as much resolution, which would be a bigger puzzle level, but if I was to make a puzzle level that looked like a number, where the individual like integers looked like a number, that would probably confuse it. It would probably be confused about as to whether or not it's playing the game or whether it's looking at MNIST. And yeah, I'm not sure exactly what it would do. Since its action set changes between environments and it knows what its action set is, it probably would adapt pretty well, but it might confuse it. I'm not 100% sure. That's not something I've tried yet either. So yeah, this is where IRIS is at right now. And if you have seen what IRIS has done in the past, this is probably not super impressive because it's not much different than it was a year ago visually, but behind the scenes it's a whole nother beast. and it's almost now to the point where I can do much more interesting tests. Once my next goal, my immediate next goal, is to yeah, see, it's still just kind of stuck on this level for some reason. Hang on a second. We'll yeah, we'll close this for a second. Okay, so I'm going to close that. I'm going to fire up the, now this is just to emphasize the point that it's the same knowledge. I'm going to fire up the driver again, and driver is going to get a much higher accuracy now. The MNIST driver is going to get a lot higher accuracy because it's already gone through and learned 600 characters. It's a random sampling out of the data set, so it's not going to be 100% because some of the characters are a little different than the other ones, but you can see it's doing pretty well here. Now if I was to, I'll close this, if I was to remove knowledge.npy, which is its knowledge, and then if I was to fire up the driver again, we're going to see, bam, its accuracy is terrible because I've erased its entire mind, and so it's starting over from scratch with MNIST, and learning through all these numbers and going through all this stuff. And then if I was to take and I was to put it inside the puzzle game again, it's also going to have trouble because it's brand new, and to the puzzle game, this is a brand new mind. And so it's having to explore and learn the puzzle game all over again. But again, see, you can see it adapts very, very quickly. And if I was to pause the process here and take and see what it's trying to think of how it's going to change the world here and all of its different plans. You can see it doesn't really know much, and it's learning all kinds of new interactions. Has no idea what's going to happen with a lot of these things that it had previously learned in the beginning of this stream. So yeah, that is where IRIS is at right now. No. You don't need to. I don't want to approve your plans anymore. Just go and be interesting in the background while I ramble on. Thank you, Iris. Okay, so next step is to separate out the causal interactions so that it's analyzing and determining cause and effects on an individual basis. So like if I was to throw it into Space Invaders right now, right? When it pushes left, its character, you know, the little Space Invaders guy will move left. The little aliens will move to the side. Maybe one of them will shoot, and maybe this little guy will shoot up. Or he's already shot up, right? And that's when it moves to the side. And when it sees things like that, it's going to, right now, with the way that the knowledge is stored, it's going to save all of that information as being caused, all those changes in the environment, the moving of the enemy, the moving of the character, the moving of the bullets, is all going to be because it pushed left. That's what it's going to see. And so that obviously is not feasible for more complex things than a simple grid world puzzle game like this. So it is going to have to separate out and process all of those individual interactions or individual effects and try and determine what the causes of those effects are. So it would have to determine, okay, when I push to the right or to the left, my little character moves, and that's one cause-effect pair, right? But if the enemy's up here and there's a space over next to it, it's going to move to the side. Right, so that's another cause and effect relationship. If there's a bullet, an enemy bullet that is moving down, it's going to move down a little bit more in the next frame, and that's another causal. If I have a bullet I shot up, the bullet is going to move up as long as there's nothing in front of it. So there's like 4 different causal interactions going on there that it's going to have to understand for it to really be able to grasp Space Invaders and be able to know that it can shoot a bullet, and if the bullet goes up and hits an enemy, it'll get points, and if a bullet comes down and hits it, it's going to die, and if the enemies come all the way down to the bottom, then it's game over, you know, all these different things, right? And so that's the next step for IRIS. I don't have a timeline for that. This is something I'm doing on my off hours when I'm not working. So I have a brand new baby. He's 6 months old now. He takes a lot of wonderful time, and I love spending time with him. But it has definitely slowed my work on IRIS. But once I get that to that point, once I get those causal interactions split out, and now that it can run so quickly, I'm not worried about how much processing it's going to take, how difficult or how long it's going to take to be able to process those interactions. Then I can throw it against the more interesting environments of like OpenAI, and that's one of the big things with my system, and one of the goals of my system was to have something that the only thing it needs is raw inputs, and it'll figure everything else out on its own. And that is currently where it's at. You give it just the raw visual inputs of this, and some non-visual data. In the puzzle game, the non-visual data is how many keys it's carrying, it's picked up, or how many fire extinguishers it's picked up. And in MNIST, it's the answer that is provided to it when it is guessing what a number is. So, like, if you show it a 5, and then you give it the label 5 as like an integer in it, it's that integer is not a visible, input, but it is like it is almost it is an input into the system that it can recognize and associate cause and effects relationships with. And that's what it's doing here. It's just looking and figuring out what the cause and effect relationships are between when it performs an action and something changes on the screen. And that is awesome. It's able to do that, and the result of that is a system that can adapt and do amazing things in some very complex environments. Now, how does that hold up against things like DeepMind? I don't know. Honestly, I don't know. I would love to see a neural network in try out this puzzle game environment. There's no neural network involved in IRIS. There's nothing like that at all in IRIS. IRIS is much more akin to like good old-fashioned AI, symbolic AI. It's all rule-based, and it's just generating the rules as it goes in from observations. And I got more information about that on the website, iris-ai.com. You can check out the latest entry in the blog. It's been last year, but it's got details about like how the system works, and how it's using causal interactions to drive its problem solving and reasoning. So I would love to see a reinforcement learning neural network in this game to try out the puzzle game environment and get some results and have something to compare it to. Because I don't know how to make a neural network. I don't know how to make a deep neural network. I don't know how to train a reinforcement learning neural network. I don't know any of that. And so I have not even tried to throw one into this. This is a very, very simple environment. I probably should throw it out there on GitHub as just the environment is just this open source thing that feeds the visual inputs and what I call the auxiliary inputs, which are the non-visual inputs, to the AI The AI processes it and sends a response back to the environment. The environment then the response is like move up or move down or whatever action command is supposed to be provided. And so I'm thinking if I can put this out there, I would love to have somebody try a reinforcement learner on this environment and see how well it does. So I have something to compare IRIS to, because it seems like IRIS is doing some really cool stuff, but maybe I'm super far behind on the curve. I honestly don't know. The other thing that is really important that I want to do, I really want to emphasize this, is that I am not an academic. A lot of times when I talk about IRIS, and I've talked with people about IRIS, and especially like organizations and universities and stuff, they want a paper, like a paper describing the functions, describing how the system works, all of that. That's not something I'm capable really of doing. I tried, because AI safety is very important to me, and so I am working closely with a lot of AI safety organizations, Future Humanity Institute, Center for Human-Centric Artificial Intelligence, which is I think it's either Andrew Critch is running it, or he's like a big part of it. He was my big contact over at MIRI before he switched over to Center, and really awesome guy, and has been very helpful. But I wrote a paper, and I sent it off to them, and it was basically like, the response I got back was, write a better paper. Because I don't know. I have no idea how to do that. So if anybody is particularly skilled or talented or has knowledge of how to write academic papers, please get in touch. I would love to work with you to write up a paper on this, and be able to have something that's publishable to explain how the system works, what it's doing, and all of that. Because I mean, the whole point of all of this is to advance the field of AI, right? I mean, that's why we're all doing this. That's why we're all interested in it. We're all trying to get to that awesome point where we have AGI. Is this AGI? No, obviously not. I mean, it's not anywhere close to AGI yet. But it's a different approach to artificial intelligence than neural networks, and it's able to produce some interesting results. And maybe that can be used along with deep learning or something, and really, advance the field further. I don't know, but sharing knowledge is important, and I want to be able to share this knowledge in a way that is in line with how the academic researchers and other researchers are used to seeing and used to processing and reading and I guess grokking all of that knowledge of a new or a different concept of a paper. Because if I, like I said, I'm not an academic. If I submitted my paper to like a technical writing class, the professor would probably laugh in my face, and so I'm kind of hamstringed right there, and I could use some help in that space. I just realized something about this level. Sorry, just kind of got distracted. The battery that's supposed to be right here, I didn't see it when the level restarted. It should have been there. That's weird. Yeah, the battery's not there. Weird. Okay. Well, I mean, it's gonna obviously it's not gonna have a reward loop issue there if the battery's not there to give it a reward, right? If it can't solve the goal, it won't have an issue. So anyway, I have a lot of work I still have to do on this. I have a lot of, but I have a lot of really cool stuff that it can do currently. So I want to keep more up to date. I really wasn't very communicative over the last year, mainly because there wasn't really anything changing other than I was trying to teach myself Python and port the code over and get it working to the point where it was a year ago in GameMaker. And now that I'm at that point, I feel like, because if I was to communicate before, I'd be like, hey, I'm still not there yet. I'm still learning Python, you know, and there wouldn't really be much point. But now I feel like as I make progress, I'm going to be more open in discussing this, and talking about where I'm at. I'll probably be doing this. I want to do more of these kind of live streams, maybe trying out some new levels and stuff, making some new stuff, trying to break the system, right? Because that's one of the important things. You have to figure out where the system's weak points are, break it so that you can really nail down better ways of doing things. So yeah, I plan on doing this probably every couple weeks. Give everybody an update on how Iris is doing, and just kind of keep going on the project. Again, if you, I'm not kidding about that academic paper stuff. If you have experience with writing academic papers and publishing them, let me know, get in touch with me, especially if you have experience with it in the artificial intelligence realm, because that is going to be very beneficial in writing it in such a way that other AI researchers will be able to read and understand. So please get in touch. My personal email is barrettcook@gmail.com. Let me know if you're interested in helping, and you know, we'll talk it over. So I'm just going to, I think I'll close it out there because we've kind of run the whole gambit here. Nobody's asking any more questions, which is perfectly fine. I appreciate all of you guys for coming and watching this. It was really great hanging out with you and talking about this. I'm gonna, in the stream that I'm gonna be doing in 2 weeks, so not this upcoming Saturday, but the following Saturday, I will be here and answering more questions as we try things out and see what kind of progress we've made. Again, thank you all for watching, and we will see you in 2 weeks. All right, bye-bye.